Hello teacher, my name is İsmail. Now I will explain how this program works. Um, First of all, I'll explain these classes. We have 4 different classes. One of is dictionary interface. This is like a list of rules that any dictionary class must follow. It specifies what methods the dictionary should have, such as adding items, getting values, and removing items. Other one is array dictionary. This is a simple dictionary that uses an array, also a list, to store k-value pairs. Other one is sorted array dictionary. This is a special kind of dictionary that extends the array dictionary. It keeps the keys sorted in order. And last one is sorted array dictionary demo. This is a demo class that shows how to use sorted array dictionary. Now I'll explain this program with debug and breakpoints. I will run with a debug. Now, in here, a new instance of sorted array dictionary is created. So inside this block, we will skip sorted array dictionaries constructor, and there is a super method, so also it skipped the array dictionary. Now the entries array is initialized with a default capacity of 25 and number of entries is set to 0. After that our super method is closed. After that we go back to demo class again. In here system.out.println adding C3. It will write adding C3 in the console in here. Now we'll call add method in sorted array dictionary. Inside the add method, in here locate index method is called, so we will go there. After that our number of entries is 0 right now and low is equal to 0, so we skip the while block right now and we return the low. After that we will back to add method again, and there is a if block, so there is number of entries is bigger than index. Now we don't have this condition, so we skip the if block, and there is a if block 2, number of entries equal to entries length. We skip it again, and there is a make room method. We will call this. When we go there, there is no entries, so it does nothing in here. And now the new entry C3 is inserted at index 0 and number of entries is incremented to 1. Entry block this k and this value is in here. We create and we defined these values C and 3. After that number of entries is incremented to 1, and now we added the C3. Now we adding in this line, write console adding a1 in here. Now we call add method again. When we go sort array dictionary, we call locate index again. Inside this low equal to 0, high equal to 0, so number of entries is 1. 1 minus 1 is 0, so high equal to 0, and mid equal to 0 right now, because low plus high equal to 0, so 0 over 2 equal to 0. Compare A in here, compare A with C at index 0 using compare to method in here. We call the compare to method for first of all we call the get method and we get the key. After that compare to, so comp equal to 0, no, so else if comp lower than 0, yes. Now high equal to mid minus 1. After that we loop again, and now this condition is not work, so we skip the in here. After that, we do this part. We get key again, and we skip this part, so we skip this part too. Make room index, we call the make room, and now shift C from index 0 to 1. This loop do this and finish. After that the array becomes A1, after that C3. We define the values right now again, and after a number of entries increment to 2, and we add A1. After that we call add method again, and it must write adding B2 in the console. We call again, so when we go there we call locate index, and we do binary search in here. Our low equal to 0 and high equal to number of entries -1, so now low equal to 0, high equal to 1, and mid equal to 0. It compare B with A at index 0 using compare to, and get key, and comp equal to 0, no, else if comp lower than 0, no, so we used low equal to mid -1. B bigger than A, so we do this part. Low equal to 1 right now. After that low equal to 1, high equal to 1, and mid equal to 1. So compare B with C at index 1 using compare to. So B lower than C, so high equal to mid -1 must work in here. This part must work. Yes, this part work, and high equal to 0 right now. In here we call compare the method twice during the binary search. First compare B with A, then with C. After that we get key method again, we skip this part and we skip this part too, and now make room part will come. Now this part shifts C from index 1 to 2. Now we define the key and value in here. After that our number of entries is incremented to 3. After that now our array becomes A1, B2, C3. So B2 at index 1 right now. Now we will add D4. It must write in the console this part like this. After that we call add method again, and we call locate index. Now low equal to 0, high equal to 2, and mid equal to 1. In here compare the D with B at index 1 using compare to. So D bigger than B, so low equal to mid +1 must run. This part must run, and we get key method again, skip, and yeah, that part is okay, and our low is 2 right now. When we go back the while loop again, first of all low equal to 2, high equal to 2, and mid equal to 2. In here compare D with C at index 2 using compare to. D bigger than C, so low equal to mid +1 in here must run right now. Skip, and this part is okay. Now low is 3. and finished it. The search terminates as low equal to 3 and the method returns index 3. In here we call 3 times during the binary search to compare two methods, comparing D with B and C and determining the insert position. After that we skip this part and we skip this part and we call the make room index. No entries need to be shifted inserting at the end. Doesn't matter, no entries need to be shifted, so we skip this part. After that insert D4 at index 3 and the array becomes A1, B2, C3 and D4. Now our number of entries is equal to 4. We define the values in here. So that number of entries is equal to 4 right now and return null. Now D is added our list. We in here we update B to 22. It must write like this. And we call that method again. Now locate index is called, and then in here our low is 0, high is 3 and mid equal to 1. Compare B with B at index 1 using the compare to. The value at index 1 is updated to from 2 to 22 and we get key. After that our comp equal to 0, so return mid. It is 22, so let's skip this part. No, I'm sorry, in this part we change the old value to new value, so we get value. After that entries index dot set value is value. After that we set value in here, value equal to new value, so now our B is equal to 22. After that system out println entries in sorted order, so in this part get key iterator returns an iterator over the sorted keys A, B, C, D, and there is a loop, so this loop runs 4 times, once for each key, and key iterator dot next returns the next k in here. After that dig dot value get value is called to get the value associated with the key, and there's a get method again. The value get value method is called to retrieve the value associated with the key, so the key value pair is print after this loop. We can see it must 4 times run. In here we do list, and after that until number of entries this loop returns. We get the values. After that get key 3, get key, after that 4 and get key. Now our loop is finished. Now case.iterator method is calling. After that our list is created, array is created. Now this part is 4 times again. In here number of entries, until number of entries it will work. Now get case and dot equals methods called and get value. After that we back again, we do same things, same methods again 4 times. A equal to 1, B equal to 22. That for C, let's do this. Entries is C, get key is 3 right now. It must write 3 in the console. yes, after that for D. Now it's works 4 times in here, like this, and finished. Now there's a D4 must write in here. Okay, now our program is finished, so let's talk about the time complexity of these methods. These methods. I want to write, so wait. Now, first of all, I want to start with add method. This part's time complexity is on. This part equal to on, because it's about the use binary search. After that, shifting elements can take on. After that, binary search it's take o log n. Shifting elements can take for make room take on time, on. After that, inserting the elements it's equal to o1. So when we get total in here, it's equal to on. Now get value method in here. In this part, loop through the entries array to find the key, so it's equal to on time complexity. Contains method in here. Contain methods calls get value, which has a time complexity of on, so it's equal to on2. There is a remove method. Searching for the key and shifting elements takes on time, so this part equal to on. There is a empty method. Simply checks if number of entries is equal to 0, so it is o1. And there is a get size method. Returns the value of number of entries, so it's equal to o1 time complexity. There is a clear method. Sets number of entries equal to 0, so that clears. It's equal to o1 time complexity. Now get k iterator method creates an array list in here, array list of keys, and returns an iterator, so it takes on time. After that, get value iterator is also similar to get k iterator, so creates an array list of values and returns an iterator, so it equal to o n. Thanks for listening. See you next week.